Section 4.8 talks about performing congruence transformations. The question is, how can you create congruent images? And there's a few different ways we're going to learn about today. Definitions. A transformation is an operation that moves or changes a geometric figure in some way to produce a new figure. An image is the new figure. A new figure produced by a transformation. So there's a pre-image and then an image. The image is the new figure. A translation is an operation that moves every point of a figure the same distance and same direction. Okay, this is basically a slide of the figure. It slides it across. Highlight that. It's a slide. You can slide it up, slide it down, left or right. It just slides it. So think of like you have a triangular object on a table or a desk. When you slide it across that table or desk, it's still the same figure. It just moved its place. A reflection is an operation that uses a line of reflection to create a mirror image. So a reflection, the best way I can think of it is like, think of you open a book and there's a picture of a triangle. When you turn the page, it kind of flips it. It flips the page over to the other side. That's kind of like what a reflection does, is it flips it over a line. And then there's a rotation, which is an operation that turns a figure about a fixed point. This is called the center of rotation. And I like to think about a rotation as this. Think of like a clock. Okay, here's the hand of the clock. Pretend there's a triangle on the end of that clock. As that clock moves and time goes on, okay, that triangle is going to be the same shape and size. It's just now in a different spot. So rotating would be like spinning it around on the hand of a clock. That's what a rotation is. Congruence transformation is an operation that changes the position of a figure without changing its size or shape. Okay, and all of the transformations we're going to do are going to be congruence transformations, at least today. So name the type of transformation demonstrated in the picture. The first one, you can see that each point is being rotated around as if it were on a clock. So this would be a rotation. Okay, the example I just kind of said with the triangle on the end of a clock hand, it just rotates around. Okay, part B. It's just every point is slid down. Okay, and then this point is also slid straight down. This would be a translation. And then part C, you see that vertical line, line V. Everything is being flipped like the page of a book. This is a reflection. Okay, and then each of these actually has rules. So a translation is going to be adding or subtracting something to the x or the y coordinate. Okay, so it's going to be x plus a number and y plus a number. So when you're moving, if you add to the x coordinate, this means like x plus 3 in the example. This means you move your x coordinate to the right 3. Plus 3 means you go right 3. If you subtract, it means you go to the left. So minus 3 would mean you subtract 3, you're going left 3. When you add to the y coordinate, it means you go up. So if it's plus 3 on the y, it would be up 3. And if you subtract from the y coordinate, it's going to be down 3. Okay? So adding to x is right, subtracting from x is left. So x's are left and right, y's are up and down. So if you look at example 2, it says to sketch figure ABCD and its image after the translation. So let's start by sketching ABCD. So A is at 1, 2. B is at 3, 3. So 1, 2, 3, 1, 2, 3. So we have A, we have B. C is at 4, negative 1. C, and then we have D, which is at 1, negative 2. So that's figure ABCD. What we're going to do now is get 4 new points. We're going to call them A prime, B prime, C prime, and D prime. We're going to minus 4 from every x value and add 2 to every y value. So if you subtract 4 from 1, you get negative 3. And if you add 2 to 2, you get 4. So again, minus 4 from the x's, add 2 to the y's. So in the new B, if you minus 4 from 3, you get negative 1. If you add 2 to the y value, you get 5. For C, if you minus 4 from 4, you would get 0. And if you add 2 to negative 1, you would get 1. And then for D, you minus 4 from 1, you would get negative 3. And then you add 2 to negative 2, you would get 0. So these would be our new points. By the way, I just want to talk about this. If it's x minus 4, that means we are going left 4. And if it's y plus 2, that means we are going up 2. So everything is going to be left 4 and up 2. So let's just check that out. If the new a value is negative 3, 4, so negative 3, positive 4. This is our new a prime. If you check that, it's going to be left 4. So I'm going to use my highlighter. Left 1, 2, 3, 4, up 2. Okay, let's do b prime. B prime is negative 1, 5. If you check that, this is to the left 1, 2, 3, 4, up 2. C prime is 0, 1. And D prime is negative 3, 0. So if I connect these dots, this shape is going to be the exact same shape as the blue one. And every point is left 1, 2, 3, 4, up 2. So you see those yellow lines are all the same, left 4, up 2. Okay, that is what a translation is. It slides it across your graph, left, right, up, and down. A reflection. Okay, the reflections are right here. If you reflect it over the x-axis, it goes to x, negative y. If you reflect it over the y-axis, your new point is going to be negative x, y. Okay, so notice what changes. The y value changes here. The x value changes over here. Okay, we will use those rules as we go forward. Okay, so you are cutting figures out of paper. Use a reflection in the x-axis to draw the other half of the figure. Okay, so just so we're aware, the rule is over the x-axis, this is our rule. So we go from xy to x, negative y. Okay, so I'm going to label these points A, B, C, D, and E. Okay, A is at negative 1, 0. B is at 1, 1. C is at 2, 4. D is at 3, 1. And E is at 1, 2, 3, 4, 5, 6, 7, 0, I believe. So those are the points. The new points, we're going to perform this rule to. So the new points, the x's are still the same. So x is still negative 1. The y's become the opposite. So the opposite of 0 is actually just 0. Let's look at B. X is the same, but the y becomes negative 1. Then we have C prime. X is the same, the y becomes negative 4. D prime. X is the same, y is negative 1. And E prime, the x is the same, the y is still 0. So notice the ones that changed were the y's. The y's became negatives, or the opposite. So if I graph this, the new coordinate plane will be, or new coordinates will be at negative 1, 0, 1, negative 1, 2, negative 4, 3, negative 1, and 1, 2, 3, 4, 5, 6, 7, 0. So to connect these dots, that's what the new shape will look like. It basically took the old shape and it flipped it over the x-axis. So it flipped it from top to bottom. Okay, that's what a reflection looks like. Okay, checkpoint. Name the type of translation below, or transformation below, sorry. This transformation is a translation. And I remember that because translation has an SL. Translation is like a slide. So a translation is a slide. Number 2, figure FGHJ has the vertices 0, 2, 2, 3, 3, 3, and 0, negative 2. Sketch FGHJ and its image after the translation of x minus 3, x plus 1. So let's start with FGHJ. So F is at 0, 2. G is at 2, 3. H is at 3, 3. And J is at 0, negative 2. Okay, so if I connect these dots, that's what F, G, H, and J will look like. So if I'm going to go x minus 3, y plus 1, what's going to happen? The x minus 3 is left 3. The y plus 1 is up 1. So if I want to just slide it, I can do it on the graph. Left 3 and then up 1. So from F, it's 1, 2, 3 to the left and up 1. This is F prime. G is 1, 2, 3 to the left and up 1. G prime. H is 1, 2, 3 left and up 1. H prime. And then J is 1, 2, 3 to the left and up 1. So if I connect these dots, the red one is the same shape, slid to the left 3 and up 1. Okay, and if you wanted to find the new coordinates, what you would do is you would take the original ones, you would add minus 3 from the x and add 1 to the y. So if you minus 3, you would get negative 3, 3. For G, you would get negative 1, 4. Because if G is at 2, 2 minus 3 is negative 1, and 3 plus 1 is 4. H prime would be 0, 4 because H, 3 minus 3 is 0, and 3 plus 1 is 4. And then J prime would be negative 3, negative 1 because 0 minus 3 is negative 3. Negative 2 plus 1 is negative 1. So you can do it on the graph, or you can do it algebraically with subtracting and adding. Number 3, figure FGHJ has the vertices F, G, H, and J, the same ones above. Now we want to sketch figure F, G, H, J, and its image in a reflection of the y-axis. Okay, so the rule here for the y-axis is you go x, y. Again, for the y-axis, it goes from x, y to negative x, y. Okay, so I'm going to put the points on here. F is 0, 2. G is 2, 3. H is 3, 3. And J is 0, negative 2. Now, what this means is you flip the x coordinate and the y coordinate's the same. So now f prime is going to be still at 0, 2 because the opposite of 0 is still 0. G prime is going to be negative 2, 3. H prime is going to be negative 3, 3. And J prime is going to be 0, negative 2. So you flip the x's for this one and not the y's. If we would graph them, F, G is at 2, 3, H is at 3, 3, and then J is at 0, negative 2. So we connect these, F, G, H, J. When you flip it over the y-axis, so the y-axis is right here. When you flip it, it's like flipping the page. So the F is still going to stay on there. The G, since G is 2 to the right, let me use a highlighter. G is 2 to the right. To flip it, you would go 2 to the left. So your G prime is going to be right here, 2 to the left. Your H is 3 to the right, so your H prime would be 3 to the left because you're flipping it to the left. So when you connect these, it's going to be like a mirror image when you flip it over that y-axis. Example 4, we'll do part A and part B here. It says to graph JK and LM and tell whether it's a rotation about the origin. If so, give the direction. So JK is at 3, 1. 1, 2, 3, 1. J and K is at 1, 4. So JK would be right there. LM is at negative 1, 3. And M is at negative 4, 1, 2, 3, 4, 1. So L, M. So we're just going to work on identifying if it's a rotation. So if it's a rotation, it's going to actually form a 90-degree angle. So if you look at K, K is right 1 and up 4. M is left 4 and up 1. So since these are basically the opposites, right 1, up 4, and then left 4, up 1, it forms a 90-degree angle. And you'll notice the same thing for J and L. J is up 1 to the right 4, and L is left 1, up 3. So if you notice this, actually, excuse me, I drew this wrong. L is in the wrong spot. Let me fix that. L should actually be, L should be at negative 1, 3. Yeah, negative 1, 3 is right here. I was right. So if you look at L, L is left 1, up 3. Notice that up 3 is not the same as, sorry, excuse me, left 1, up 3. So left 1, up 3, and up 1, right 3 form a right angle as well. So this is a rotation, even though all my chatter made it seem like something was wrong. It is a rotation. You're taking that blue line and you're rotating it counterclockwise 90 degrees. So this would be 90 degrees counterclockwise. (90° counterclockwise). Okay, if we look at part B, if we graph JK, J is at -2, 1, and K is at -1, 1, 2, 3, 4, 5. So we got JK. Right, and then we have LM, which is at 1, 1, and M is at 2, 5. 1, 2, 1, 2, 3, 4, 5. So if you look at this, we want to find out, is it a rotation? So we have to look at the slopes again. So if you look at from, let me get a highlighter actually, from the origin to this 1, 1 is up 1, right 1. And from the origin to J is up 1, left 2. So those are not the same distance, up 1, right 1, and up 1, left 2. And they don't form a 90-degree angle. So this is actually not rotation. It's not a rotation. So we're just trying to find out if it's a rotation or not. It's going to be a 90-degree angle, and the slopes will be opposite reciprocals. So like positive 1 over 1 is not an opposite reciprocal of positive 1 over -2. But over here, if you look at the green lines, up 1 to the right 3, that was in green, is an opposite reciprocal of left 1, up 3. So up 3, left 1. Those are opposite reciprocals, so it is a 90-degree rotation. All right, we're going to skip the checkpoints. And example 5, we're just going to quick talk about it, and this will be the last one for the notes. Vertices P, Q, and R are given. The notation of x, y to x plus 1, y minus 6 describes the translation. Explain how you would show that triangle PQR is congruent to triangle XYZ. Okay, I'm not going to draw the graphs right here. We would graph them, so I can draw one of them, I guess. 2, 2, 3, 4, 5, 2. So this would be PQR. And if you graphed it, it would be to the right 1 and down 6. So how can you verify that these are congruent? We could check distance formula to show side, side, side congruence. So you could do distance formula and show side, side, side congruence would be the way you would verify this. I just want to point out that any translation is going to be congruence. And the way we could prove it is side, side, side. We're actually not going to prove it, but that's how we would do it. Okay, and I'm going to stop there. We're not going to do the checkpoints. We'll talk more about this in class.